So now our next agenda item is to review the system Verilog code of the assertions. So here we can see this module with these inputs that we are since monitoring all the signals from our arbiter FSM code, all the inputs and outputs. So we have like we use logic analyzer, we have put the probes onto all the input outputs of our uh, FSM module. So here is our first property, which says that FSM should always behave as one hot state machine. So here is our property that at POSIX clock the state should be one hot. Means that every time we have a positive edge of clock, we should see a state in which only one bit is 1. And here we are asserting this property. The name is as given here, and here is the cover property to show that okay, whether this part has been covered or not. Next come that from idle state the FSM cannot go to idle 1, idle 2 or idle 3. Means that after this idle we go to these idle 1, 2, 3 through some master 1, 2, 3. So here we see this property how we can verify this thing. So if state is equals to idle 1 or state is equals to idle 2 or state is equals to idle 3 and reset is inactive, in fact reset is inactive on 1, means it is inverted logic. So the past state cannot be idle state. So in this way we can say that if we are in idle 1, idle 2 or idle 3, past state cannot be the idle state. So this is the second assertions, and here we have asserted this property. So in third assertion, this check makes sure that if the FSM insists in certain master state, then next transition will always be some idle, means master 1, 2, 3, then we will be in idle 1, 2, 3. So first we see for this master 1 that if we are in idle 2 state or in idle 3 state or in master 2 state or in master 3 state and reset is inactive, the past state cannot be master 1. So this was for the this first part. That property says that in case of idle 2 or idle 3, master 2 or master 3, the previous state cannot be a master 1 state. And here we are putting an assert property that use this property, and then we see whether this property is covered once we write the test bench or not. So this was about master 1. Similarly, we go into master 2, that if our state is idle 1 or our state is idle 3 or master 1 or master 3, then the previous state cannot be master 2. In fact, in all these three properties, we are verifying the state machine, that we from master 2 we cannot jump into any of these states. Similarly, on here we have this asserted property, and here we are covering this property. Now this is for the third one, the third case, that if we are in master 3 state, the previous states cannot be idle 2, idle 1, master 2 or master 1. And again we have asserted and covered them. So the fourth assertion, this check makes sure that the FSM will always transition to a master state from an ideal state, assuming that FSM is not received. So here we can see if state is equals to idle 2 or state is equals to idle 3 and reset is inactive, past state cannot be an idle one. So means that from idle 1 we cannot jump into idle 2 and idle 3. Similarly, and now here we have asserting and covering this property, and then we see if state is equals to idle 1 or idle 3, the previous state cannot be idle 2. Conversely, idle 2 in we cannot jump into idle 2 from idle 1 and idle 3. Sorry, we cannot from idle 2 we cannot go into idle 1 or idle 3. And here we have this assert and cover property. Finally, for idle 3 state, so from idle state 3 we cannot jump into idle 1 or idle 2. And here we are asserting this property and covering this property. And here we have that there should be a grant for every request sent to the arbiter. That say if any of the request 1 or request 2 is 0 and reset is inactive, then after one cycle we will either have grant 1 or grant 2 and grant 3. And here the request listing. Finally, we check for the fairness of the arbiter, make sure that all masters are getting equal number of grants. So here we have this property that if request is inactive, request 1 is there and reset is inactive, that after one cycle grant will be given to the first user. And here we are using this cover property. Again we can see for the property 2, we say if there is request 2 available and reset is not there, then after one cycle we should have grant 2. We are putting it into this cover property. And then for the third one, that if there is request from third user and reset is inactive, then we have a grant. Okay, so now here is